Hey guys, in this video I am sharing 60 plus real scenario based and tricky microservices interview questions. Okay, and trust me, after watching this video you won't need to go anywhere else to prepare for microservices questions. Okay, and if you are preparing for Java, Spring Boot, microservices interview, then please make sure to subscribe to this channel. So now let's get started. First question is, you have three microservices: order service, payment service, and inventory service. Order service calls payment and then payment calls inventory. So what happens if payment succeeds but inventory service fails? So guys, if payment succeeds but inventory fails, we get an inconsistent state. Okay, money is deducted but the item is not reserved, so the order cannot be completed. Okay, so to fix this, we should use rollback refund mechanism where payment is reversed, retry mechanism where try inventory again, saga pattern where automatically undoes previous steps. Okay, are you getting my point? So guys, next question is how saga pattern automatically undoes. Could you please explain its mechanism thoroughly? So guys, saga pattern works like a step by step transactions with a backup plan. Here in this, a big process is broken into the smaller steps. For example, order, payment, and inventory. Each step completes its own work and saves it. If all steps succeeds, then it means process is done. If any step fails, then it means systems runs. Compensating action means undoing steps. Are you getting my point? For example, if payment succeeds but inventory fails, then Saga triggers a refund to undo the payment. Okay. Next question is, guys, could you please explain choreography and orchestration styles of Saga pattern? In choreography, there is no central controller. Each service works independently and reacts to events. For example, when order service creates an order, it sends an event. Payment service listens to it, process payment, and then sends another events. Inventory service listens and continues the process. So basically, service talk through events and decide themselves what to do next. Okay. Whereas in orchestration, there is a central coordinator that is called orchestrator that controls everything. It basically tells each service what to do step by step. For example, the orchestrator tells payment service to process payment, then tells inventory service to update the stocks. If something fails in between, it also tells service how to undo actions. Are you getting my point? So here one central service manages the whole flow. And next interesting question would be, guys, each microservice has its own database, but sometimes you need data from another service. So will you call another service every time or duplicate the data? So this is very tricky question. So basically in microservices, we should not call another service every time because it can slow things down and create dependency between services. Okay. Instead, a common approach is to duplicate only the required data called data replication. Services shares update through events, so each service keeps a small copy of the data it needs. This makes system faster and more reliable. Okay. Before moving to the next question, guys, I want to share something important with you. Actually, people are cracking interviews and getting jobs after preparing with interview preparation kit. Okay, and you can check the reviews as well. So, guys, let me tell you, this interview preparation kit has four main parts. Okay, first is complete interview preparation material. It is a step-by-step material made by me, expert and MNC's interviewers. 99% of the questions asked in interviews are covered in it, right? Second is two real enterprise client projects. Code and video recorded sessions are there. Okay. And third is lifetime chat support. Here you can ask your doubts anytime, right? Fourth is referral support. Here we help you to get referred to the top MNCs. So basically the material is organized as per your experience level and covers Java, Spring Boot, Spring Security, Spring Data, JPA, microservices, Kafka, Maven, Git, coding questions, Stream API coding questions, and many more. You can buy just the complete interview preparation material or the full interview preparation kit with project supports and referrals. I have added the links in the description below. So now moving to the next question. Guys, next question would be, why does each microservice should have its own database? So basically each microservice should have own database to stay independent. This is the first thing. This means one service can change, scale, or even fail without affecting others. If multiple services share the same database, they become tightly connected. A small change in one service can break others and making the system hard to manage. Okay. Next question is, guys, your system has an API gateway and suddenly traffic increases heavily. So what would you do in this situation? First, we would scale the API gateway horizontally and add more instances and put a load balancer in front to distribute traffic. Okay. Second, we would apply rate limiting so one users cannot overload the system and use caching to reduce a repeated request. Third, we would use a queue like Rabbit or Kafka for heavy operations so requests don't fall immediately. Okay. And the next question is, guys, why should we use an API gateway instead of calling service directly? So very important question. So basically, we use an API gateway to simplify and secure communication between clients and microservices. If client calls services directly, they need to know multiple service URLs, handle different responses, and manage complexity. With an API gateway, the client calls one single entry point and the gateway routes the request to the right service. Okay. It also handles common tasks like authentication, logging, rate limiting, and caching, so each service doesn't have to do it. So, guys, next question would be, in microservice architecture, share the scenarios when would you choose synchronous and asynchronous. So, guys, we should use synchronous communication when we need an instant response. For example, login, payment confirmation, validate users, etc. We should use asynchronous communication when work can happen in the background. For example, sending emails, notifications, updating reports, analytics, long running tasks, and reducing load during high traffic. Okay. And the guys, next question would be, one of your service is down, but your application keeps calling it repeatedly. How would you handle this? So if one service is down and our application keeps calling it again and again, it can overload the system and make things worse. Okay. To handle this, we use a few simple techniques. First technique is circuit breaker. It means stop calling the failed service for some time. After repeated failures, let it recover. Okay. Second is retry with delay. Instead of calling immediately again, wait like a few seconds before retrying. Are you getting my point? Third is fallback. Show a default response like service unavailable or try again later instead of failing completely. Okay. And fourth is timeout. Here, don't wait forever for response. Wait only for a fixed time. Say 2 seconds, then stop and move on. Are you getting my point? And guys, next question is, a request fails somewhere across 5 microservices. How would you debug? So first we should start by tracking the request end to end. Okay. Then use a request ID so we can follow the same request across all microservices in logs. Okay. Check logs step by step to see where it fails. Are you getting my point? Then check each service one by one. Look at the logs, errors, and response codes. Verify if any service is slow, down, or returning wrong data. Check dependencies like database, API calls, or queues. Are you getting my point? Finally, use tools like distributed tracing, for example, Zipkin or any other tool, and monitoring dashboards to quickly spot the failing service. Once found, fix the issue, add alerts to catch it earlier next time. Okay. Guys, next question is, you want to deploy a new version without downtime, how would you do it? So guys, we should use zero downtime deployment techniques here. First is blue green deployment. Here, run old and new version side by side. Switch the traffic to the new version once it is ready. Okay. Second is rolling deployment. Update server one by one so the application stays live. Are you getting my point? Third is canary deployment. Here, release to a small group first, then gradually to the users. This way, users don't face any downtime during the updates. Next question is, guys, a service fails due to temporary issues. So how will you handle this situation? So guys, in this situation, we should use retry and delay mechanism. If service fails, wait for a few seconds and try again. We say retry, limit retries, example 3 times to avoid overload. Okay. We could use circuit breaker here as well. If it keeps failing, stop calling for the some time. Okay. We could also add fallback like show try again later or use cache data. Okay. Next question is, guys, let's say a payment API is called twice accidentally. How will you ensure duplicate payment doesn't happen? So here we should use idempotency, basically send a unique transaction ID with each payment request. If the same request come again, system checks ID and ignores duplicates. Store request status to prevent double processing. Okay. Next question is, guys, in microservices, how would you handle transactions across multiple services? So in microservices we don't use one database transaction across services like in monolithics, because each service has its own database. Okay, instead we use the saga pattern. As we already covered this in the earlier question, the transaction is broken into the small steps and each service complete its part. If all steps succeeds, transaction is complete. If something fail in between, we don't roll back like a database. Instead we run compensating action, means undoing steps. For example, if payment is done but inventory fails, we triggered a refund. Are you getting my point? Next question is, guys, if one service is getting heavy load, so how will you scale it? We can scale horizontally by adding more instance of the service and use a load balancer to distribute traffic. We can also enable auto scaling, so instances can increase or decrease based on the traffic. Are you getting my point? If needed, we can also optimize code or add caching to reduce the load. Okay. And the next question is, guys, you have 10 microservices with environment configs. How will you manage these configs across those microservices? So here we will use a centralized config management system where all configs are stored in one place. Each service will fetch configs from there. This helps in easy updates, consistency, and avoids hard coding in configuration in services. Are you getting my point? Next question is, guys, your service works fine in lower environment but fails in production. How would you debug it? First, we will check the logs to find the errors, compare configurations between environment and verify environment variable. We will also check the data differences and external dependencies. If needed, we could also try to reduce the issue in staging environment. Okay. And the next question is, guys, let's say service A calls B, service B is down. So what would happen? So in this case, service A's request will fail or get delayed. To handle this, we can use retries with that limits, timeouts, and circuit breaker pattern to stop repeated calls. Also, we can return a fallback response so the system doesn't completely fail. Okay. One microservice is slow and impacting the system. What would you do? First, we will find the causing using logs and monitoring. Then we can optimize the codes, improve the database queries, or add cachings. Okay, we could also scale the service like adding more instances. Okay, also we could use timeouts or async calls to reduce the impact on the services. Are you getting my point? And the guys, next question is, how would you handle security in microservices? First, we will secure APIs using authentication and authorizations like JOT or OAuth, and use HTTPs for all communication. Okay. Then we will validate inputs, avoid exposing sensitive data, and use API gateway for centralized security. Okay. Each service should have proper access control and secrets should be stored securely. Next question is, when should we not use microservice architecture? So this is very important question. So we should not use microservices for a small or simple application. If the team is small or not experienced, it adds unnecessary complexity. Also, if strong coordination and fast deployment are needed, monolithic is better. Microservices are useful only when the system is large and needs scalability. Okay. Let's say two services update the same data at the same time and causing data conflicts. So how will you handle concurrent updates in microservices? So this is very interesting question. So guys, there are several ways to handle concurrent updates. First is optimistic locking. So here we add a version number to data. When updating, check if version is still same. If changed, then reject and retry. Are you getting my point? For example, let's say service A reads version 1, service B updates and now version becomes 2. Service A tries to update but rejected due to version mismatch. Okay. Second is pessimistic locking. Here we log the data while updating so other services must wait. It is good for critical data but slower than optimistic locking. Okay. Third is idempotency. Here we ensure same request doesn't update data twice. Let me tell you how it works. Each request has a unique ID known as idempotency key. System stores it, and if same ID comes again, then ignore or return old response. Are you getting my point? Second question is, guys, suppose a service publishes events but due to a bug it starts sending incorrect data to multiple services. So how will you prevent this? This is also very interesting question. So actually there are several ways to prevent this. Every service should double check incoming data like rules, schema, and required fields. We must define a fixed event format like a contract, and if the event doesn't match, then ignore it. we should use idempotency technique to make updates safe. So even if bad data comes twice, it doesn't keep corrupting things. Are you getting my point? We should also use circuit breaker. If one service starts sending bad events, then stop consuming from it temporarily. We should also monitor the logs, graphs, and alerts regularly. Next question is, guys, you have a centralized logging system, but logs from different services are hard to debug. So how will you trace a request across services? So in order to fix it, we need a way to tie all logs of one request together. Okay. When a request starts, we should generate a unique ID, for example 123 or any number or alphabet. Okay, then we have to pass this ID to every service via headers, and every service logs this same ID. Okay, now we could search logs using that ID and see the full journey of the request. For example, user made a request to service A, to service B, and then service C. Then there would be a single trace ID for all the service logs. Are you getting my point? Next question is, guys, your system uses message queues, but messages are getting stuck and not processed. So how will you debug and fix message backlog issue? So this is also very interesting question. So basically it's like a traffic jam. Vehicles are getting stuck and not able to get the clear road. So we have to find where the jam is happening and fix it. Are you getting my point? So first we have to check whether there is a bad message that is blocking everything. If it is there, then we have to remove or skip that bad message, because sometimes one message keeps failing again and again. Are you getting my point? Second is, we have to check whether the services are running successfully, because they may be crashed or stopped. So that case we have to restart those. Okay. Third, we have to check the number of worker or services instances. If they are one, then we have to increase those. Okay. Fourth is, we have to check whether the workers or services are too slow. If yes, then we have to check the slow APIs and improve the performance. Okay. And finally, we have to slow down the incoming task if these are coming too fast. For example, if 100 tasks per second coming but only processed 10 tasks per second. Okay. Next question is, let's say a service is accidentally exposed to outside and starts receiving malicious traffic. So how will you secure your internal services? So in order to secure our internal services, we could follow several steps. First is, don't expose internal services directly. Basically, internal service should not be public. Put them behind an API gateway, and only the gateway should be exposed, not our services. Are you getting my point? Second is, restrict who can talk to whom. Even inside system, don't trust everything. Allow only specific services to call each other and block unknown requests. Okay. And add authentication between services. Each service should prove its identity by tokens like JWT. If too many requests come, then we should use rate limiting to limit the request per second. Are you getting my point? Next question is, let's say you need to release a feature to only 10% of users initially. So how will you implement the feature rollout? So we would take a stable identity like the user ID, generate a consistent number using hashing, and assign each user to one of the 100 buckets using modulo. Then we would enable the feature only for bucket 0 to 9 to achieve roughly 10% rollout. Are you getting my point? So this ensures the same users always see the features without it changing randomly. Okay. Next question is, guys, suppose that your microservices system has too many inter-service calls and causing high latency. So do we have any solution to reduce this latency? Yes, we can reduce the latency by these solutions. Instead of calling 5 services or more services separately, we should create one layer that fetches all data in one go. Okay. And then don't call service again and again for the same data. Instead, we should use caching. Okay. Analyze and avoid unnecessary and repetitive calls. Are you getting my point? And also, we could use async communication, and now we don't have to wait for every response. Okay. So guys, next question is, let's say you are migrating a monolithic to microservices, but some modules are tightly coupled. So how will you break them into services safely? So we could add the timeouts, and now we don't have to wait for the slow services. Okay. We could also use caching for the repetitive data calls. We could also increase the instance of the services in order to decrease the latency. Are you getting my point? Moving to the next question, guys. Let's say your system has multiple services deployed globally, but user face latency issues based on location. So how will you design for low latency globally? When users are in different parts of the world, delay happens because data has to travel far. To fix this, we would place our services in multiple locations or regions so user connects to the nearest one. Are you getting my point? We would use routing to send each user to the closest server automatically. We would also store frequently used data in cache or CDN so it loads faster from nearby. For databases, we would keep copies in different regions so data can be read locally. This way, users don't have to wait for data to travel long distances and everything feels faster. Are you getting my point? Next question is, guys, assume that one service works on critical financial data and failure is not acceptable. So how will you ensure high reliability and fault tolerance to your client or project manager? So first we would run multiple instances of the services. So if one goes down, other continues working. Okay. We would store data safely using replications and regular backups to prevent loss. Are you getting my point? We would also use retries and failover mechanisms. So if one component fails, another task over automatically. To avoid wrong data, we would use transactions and validation checks. Okay. Next question is, guys, let's say you need to process millions of requests per second. So how will you design your microservices for extremely scalability? First, we would keep services stateless so we can quickly add more instances when traffic increases. Okay. Then we would use horizontally scaling, means adding more servers instead of bigger ones behind a load balancer to distribute traffic evenly. Then we would use caching to reduce repetitive works and database load. For heavy or non-urgent tasks, we would use asynchronous processing so requests don't block. Are you getting my point? We would also use database scaling techniques like sharding and read replicas to handle large data loads. And finally, we would monitor traffic and auto scale services based on demand. Okay. Next question is, guys, let's say you have deployed a service successfully, but suddenly you observe that there is a CPU usage spike. So how will you debug this production performance issue? First, I would check the recent code changes. If they are buggy or there are infinite loops, then definitely we will roll back and fix it. Are you getting my point? If the code is not buggy, then we would check the traffic. If request suddenly increases or system is overloaded, then we would scale more instances. Okay. We have to identify heavy APIs as well. There may be a chance one API is being called too much. Okay. We will also check DB queries, and if they are heavy, then we have to optimize those as well. Are you getting my point? Moving to the next question, guys. Let's say your system needs to support real-time updates like chat or notifications. So how will you design this in microservices? So to support real-time updates like chat or notifications, I would keep a live connection between the clients and servers using something like WebSockets. Okay. So the server can push updates instantly instead of the client repeatedly asking for them. Are you getting my point? When an event happens like a new message, it is sent to a message queue, and a dedicated notification or chat service picks it up and delivers it to the user in real time. Are you getting my point? I would also store messages in a database so users can see them later and handle offline users by saving messages and sending them when they come back online. Are you getting my point? So this way the system stays fast, scalable and reliable. Next question is, guys, assume that you are using third party APIs and they start failing randomly. So how would you debug and resolve this issue? So basically, when third party API starts failing randomly, we would first confirm and understanding the failures by checking logs, error codes and patterns like timeouts or specific endpoint failing. Then we would verify if the issue is from their side by checking their status page or trying the API manually. Are you getting my point? To protect my system, I would also add timeout so we don't need to wait too long. To protect my system, I would add timeout so we don't wait too long and use retries with limits for temporary failure. I would also implement a circuit breaker so if the API keeps failing, we stop calling it for some time and avoid overloading our system. Okay, for better user experience, I would also use fallbacks like cached or default responses. Are you getting my point? Next question is, guys, let's say you notice that a single user request triggers 50 plus internal service calls. So is this a good design? And if not, how will you fix it? So actually this is not a good design, because one request triggering 50 plus calls means higher latency, more chances of failures, and unnecessary loads on the system. To fix this, I would first try to reduce the number of calls by combining multiple calls into the single request using an API composition layer or gateway. Are you getting my point? I would also check if some data can be cached so we don't call services repeatedly for same information. Okay, if certain data is needed frequently, I might store a copy locally to avoid calling another services every time. Okay. Next question is, guys, if network latency increases, will microservices still be a better than monolithic? Actually, the answer is no. If network latency increases, microservices can actually become worse than a monolithic in some cases. In microservices, services talk to each other over the network, so higher latency means every calls takes longer and multiple calls can slow the system a lot. In monolithic, everything runs in the same process, as we know, so communication is much faster and there is no network delay. Are you getting my point? So if your system has many inter-service calls and high latency, a monolithic can perform better. Next question is, guys, how would you test microservices? Please share at least 2 3 strategies. So to test microservices, I would use a few simple but effective strategies. First, unit testing, where I test each service's logic independently by mocking external dependencies. This ensures the service works correctly on its own. Are you getting my point? Second is integration testing, where I test how services interact with each other or with the database and APIs. This helps catch issues in communication between services. Third, end-to-end testing, where I test the complete flow like a real user request across multiple services to ensure the whole system works together properly. Okay. Next question is, guys, how would you scale databases in microservices without any downtime? So to scale databases in microservices without downtime, I would avoid making big changes all at once and instead scale gradually while the system is still running. Are you getting my point? I would also add read replicas to handle more read traffic and reduce load on the main database. And for heavy scale, I would use sharding to split the data across multiple databases. To avoid downtime, I would run the new setup alongside the one and shift traffic slowly. We call it rolling or blue green approach. This way, users are never affected while scaling happens in the background. Are you getting my point? And next question is, how would you handle schema changes in microservice architecture? So for handling schema changes, I would follow a backward compatible approach so old and new versions of services can work together. For example, instead of modifying or deleting a column directly, I would first add new fields, update the services to use them, and only later remove old ones. I would also deploy the changes in steps and ensure both schemas work during the transition. Are you getting my point? Let's say two microservices show different data for the same user. So how will you identify and fix this inconsistency? So basically, first I will check the logs, timestamp and database values to see where the data is different. Okay, I will also trace the request flow using monitoring tools, right? Then I will fix the root cause like missed events or delayed updates. Okay, and I will also use event driven communication or retries to sync data. Are you getting my point? And in the end, I'll add proper logging and alerts that will help avoiding this issue again. Okay. Now moving to the next question. A service is returning stale data due to caching. So how will you handle cache invalidation? So basically, stale data means outdated data. Okay. To fix this, we will use cache invalidation strategies like TTL, right? Or event based updates. Okay. When data changes, we will clear or update the cache immediately. Okay, we can also use cache aside patterns so the fresh data is fetched when needed. Okay, next question is, suppose multiple services updates the same data in different orders. Okay, so how will you maintain the data integrity, right? So the answer is, to maintain the data integrity, we will use the techniques like versioning or optimistic locking to avoid overwriting changes. Are you getting my point? We can also use a central service or event queue to control update order. Okay, and hence this ensures updates happens in the correct sequence and no data is lost. Okay. Next question is, half of your services become unreachable due to network failure. So what would you do and how should your system behave? So guys, first the system should gracefully not crash, right? We should use timeout so requests don't hang forever, and circuit breakers to stop calling failing services and return fallback responses like cache data or partial results. Okay. Also trigger alerts and auto recovery like restarting on rerouting traffic, right? So the system should stay available for working parts even if some features are temporarily limited. Are you getting my point? Next question is it possible to design a system with both strong consistency and high availability? So guys, basically in the distributed system, due to cap theorem, we usually can't have both during network failures, right? We must choose strong consistency, which means correct data but possible downtime, or high availability, which means always responding but maybe slightly outdated data. Okay. And in normal conditions we can balance both, but during partitions one has to be sacrificed. Are you getting my point? Next question is, let's say you have implemented retries but now they are increasing system load. So why does this happen and how will you fix it? So retries increase load because failed requests are sent again, creating extra traffic like retry storm. This can overload already struggling services, right? To fix this we should use exponential backoff like increase wait time between retries, right? Limit retry count, okay? Add jitter like random delay, okay? And use circuit breakers to stop unnecessary retries when a service is down, right? Next question is, a service is working correctly but has very high latency. So how will you debug this? So guys, basically we will start by checking metrics like response time, CPU, memory and network latency. Okay. Then we will look at the logs and use tracing to find slow steps, right? Like DB calls, external APIs. Okay. We will also check if queries are unoptimized or if there is a thread blocking. Okay. Then we will verify cache usage and connection pools, right? And finally in the end we will fix by optimizing queries, adding caching, scaling the service or reducing the unnecessary calls. Are you getting my point? Next question is, your message queue is producing duplicate messages, so how will you handle duplicate processing? Okay, so basically we will handle this using idempotency. Okay, each message should have a unique ID and the consumer should track process IDs in DB or cache, right? If the same message comes again, then ignore it. Okay, this ensures even if duplicate occurs, processing happens only once and data remains correct. Are you getting my point? Next question is, messages are getting processed out of order. Now how will you ensure the correct sequence? Okay, so basically to maintain order we should use partitioning like same key to the same partition, right? So messages are consumed sequentially. Okay, add sequence numbers in messages and reorder at the consumer if needed, right? In critical cases we should use a single consumer or enforce ordering at the producer side, right? This ensures correct sequence processing. Are you getting my point? Next question is, you have a system with very high read traffic but low write, so how will you design it using CQRS? So guys, basically CQRS stands for command query responsibility segregation. Okay, and here we separate read and write operations. Okay, for high reads we created a dedicated read database optimized for fast queries like denormalized data or indexes. Okay, writes go to the separate write service and database. Okay, after a write, data is asynchronously synced to the read side using events. Okay, this improves read performance and scalability without affecting the writes. Are you getting my point? Next question is, after implementing CQRS, users sometimes see outdated data. The question is, why is this happening and how will you fix it? So this basically happens due to eventually consistency, right? After a write, it takes time for data to sync from the write model to the read model, right? So users may see the old data. Are you getting my point? To fix this, we can reduce sync delay, use real-time event streaming, show data is updating messages, or for critical cases, read directly from the write database to ensure fresh data. Next question is, when should you not use CQRS in microservice architecture? Okay, so this is a good question. So we should avoid CQRS when the system is simple, has low traffic or doesn't need high scalability, right? It adds complexity like managing two models, syncing data, and handling consistency issues, right? If a strong consistency is required, like banking transaction, or the team is small, then CQRS may create more problems than benefits. Are you getting my point? Next question is, what happens if API gateway goes down and how will you design for high availability? So basically, if the gateway goes down, all clients should fail because it's a single entry point, right? To avoid this, deploy multiple gateway instances behind a load balancer. Okay, we should use health checks, auto scaling, and multi-zone deployment so the traffic shifts automatically if one instance fails. Are you getting my point? We can also keep fallback or secondary gateway to ensure zero downtime. Okay. Next question is, you need different responses for mobile and web clients. So how will you design this? So guys, we should use a backend for front end pattern, that is BFF pattern. Okay. Create separate backend layers for mobile and web clients. Each BFF tailors responses based on client needs. Lighter data for mobile, richer data for web, right? This avoids overfetching and keeps front-end logic clean. Okay. Another option is versioning and adding client-specific fields in APIs, but BFF is more scalable. Okay. Next question is, a service instance goes down but traffic is still routed to it. What would be the problem here? Okay. So this usually means health checks or service discovery failed, right? The load balancer didn't detect that the instance is unhealthy. Okay. So it kept sending traffic, right? It could be due to misconfigured health checks, delayed updates in service registry, or caching issues. Are you getting my point? We can fix this by using proper liveness, readiness checks, and ensuring fast failure detection and removal from routing. Okay. Next question is, how will services discover each other dynamically without hard coding URLs? Okay. So basically, each service register itself with a registry like Eureka or console. Okay. Other services query the registry to get the latest available instances instead of using fixed URLs. Are you getting my point? We can use client-side discovery like service calls registry directly, or server-side discovery like via load balancer. Then this makes the system flexible and handles scaling automatically. Okay. Next question is, auto scaling adds new instances but they are not receiving traffic. Then what would be the reason? So basically, this usually happens when new instances are not properly registered or marked healthy, right? Possible issues include failed health check, delay in service registry update, or load balancer not refreshed. Are you getting my point? Sometimes readiness props are not configured, so instances are considered not ready. Okay, we can fix this by ensuring proper registration, correct health readiness checks, and fast propagation to the load balancer. Okay. Next question is, guys, one internal service is compromised, so how will you prevent damage to the entire system? So basically, we should apply zero trust and isolation principles here. We will use authentication between services, limit permissions, and isolate service via network policies, right? We should add rate limiting and circuit breakers to stop spreading failures. Okay. Also monitor and quickly revoke excessive suspicious activities detected. Okay. This ensures one compromised service cannot freely access or damage others. Are you getting my point?